Hi everyone, this is Pedro from Pythalista with one more video. I've talked about Docker in many of my videos, but I never really gave an introduction of what Docker is and really explained for you to understand what are the fundamentals of Docker. In this video, my goal is for you to understand once and for all what is Docker, an introduction to Docker. So, what is the problem that we're trying to solve when we are using Docker? Usually when you are developing an application, so a developer needs to install into the developer machine some configuration of the operation system, install some libraries, SDK, as I said, OS dependencies, and then let's call it your development environment. But at some point you have to deploy this application to production. And there is a famous meme of it works on my machine. So Docker wanted to solve this problem. And that's the DevOps handover problem. So it's all working on a developer machine, but we need to quickly reduce the cycle of development and deployment. That's where the DevOps movement started. So the idea of people that started DevOps movement, and for that, I really recommend these two books here, DevOps Handbook and the Phoenix Project, where a quote that summarizes what DevOps all about is: imagine a world where product owners, development, QA, IT, operations, and InfoSec work together not only to help each other, but also to ensure that the overall organization succeeds. So that's the modern stack for DevOps, and Docker is right here. So, but anyway, what is Docker? Docker is a container technology, and Docker is not only the only container technology. And that begs the question, what is a container? So from the docker.com source, we can see here, simply put, a container is a sandbox process on your machine that is isolated from all other processes in the host machine. That isolation leverages kernel namespace and groups features and have been in Linux for a long time. In summary, containers are runnable instances of an image. Containers are isolated from each other and run their own software, binaries, networking, volume, data, and configurations. I think the best way to understand what a container is to compare with a virtual machine. So usually a virtual machine, it's a hardware like a host operation system. And then a hypervisor is installed on your system. And then you can kind of partition that machine memory and CPU to machines that lives into a machine. But every single machine, virtual machine that's installed in a host OS has its own operation system. And in summary, this is heavy and slow. It can take minutes to start. And the size of a virtual machine, because there's so many overhead, it's on the gigabyte size. However, a Docker container is a virtualized OS. It usually starts up in seconds, as you will see in a demo. The size usually is megabytes. It's lightning fast because what Docker is using is just isolating a process that you want to run your application. Before the demo, there are three concepts of the life cycle to build a Docker image. Usually you have a Docker file. You can run a Docker container without a Docker file, but since the objective is to have infrastructure as code, a Docker file is where you define your image, and then you have to, a second step, build the image, and the Dockerfile is kind of like the blueprint, and the Docker image is like your template. And then you have to run your application, and then run that image, sorry. And then once you run that image, that's a container. So, and our container always have a process running. Now let's go to the demo. Before I go to the demo, if you wanted to follow me here, you have to install a Docker Desktop. So you can install it in Mac, Windows, or Linux. I'm using a Ubuntu WSL, and I'm here in VS Code. So let's create a Docker file and create a simple image. So the minimum that you have in an image is a image that you can get from Docker Hub or a Docker registry. Our case here, I'm just gonna run a very light distribution of Linux called Alpine, and then I'm just gonna go put latest, and then I'm just run a simple executable here, which is the sleep command in Linux, and I'm just going to sleep for, let's say, 10 seconds. And then that's my Docker file. So once I have Docker installed, I can then run the command docker build this container. I usually put a tag. So remember the process. I had Dockerfile image and then run the image as a container. So I'm just gonna give the name of my Docker Hub account. You don't need to give that. I'm just putting that because in the case I wanted to upload these to Docker Hub. I have other videos that I've done that demonstrating how to deploy an application. Okay, I'll put the link here on the video on the top right. So I'm just gonna call this Alpine Sleep. And then I'm just gonna put dot, which is the context of my Docker file, which is in the current directory. So if I do that, that's gonna build that image. I think I need to call it Docker file. And I think now it's all good. That's just a small mistake. Now I have an image. If I do Docker image ls, and then I have lots of images here. Is the Alpine Sleep here. Now to run this, I do a command line docker run, and then I put the name of the container, which is Pedro Queira, Alpine Sleep, and then run. So, and then if I do a docker ps, my container is not running anymore. Why? Because that process starts, and then after 10 seconds, there's no process running. The container is stopped. So let me just open another terminal here. Then I do a docker ps, and then docker run. If I do a ps, can you see that container is running? And running is 4 seconds, 6 seconds, 7 seconds. The container is running and then stop running. So we need to create a persistent process, and let's create like a very quick Python API here using Fast API. Just gonna take the less than a minute to write this application because we are using Python. Okay, let's start this application locally just to see if that's working. before I containerize this application. Yeah, the application is working. I'm just gonna open here. It's just like hello world application fast API. It's working here on my local host. So let's stop the application. And then to containerize this application is pretty simple because it's a simple application. Stop development server. And then I'm just gonna, I use the same Docker file here. I'm just gonna delete that. And then I'm just gonna create a new application here on the Docker file. And then I'm just gonna install Python 3.11, which is the latest Python. And then I'm just gonna first create a working directory. And then I'm gonna, to this working directory, I'm just gonna copy my requirement txt file, which is this one. And then I'm just gonna install my dependencies and apt pip. And then I'm just gonna copy just my API code here to that working directory, to the this one. And then because I'm running that in production, the starting command is going to be a little bit different. I'm running port 80 instead of port, I think before was on port, I think was 36846 or some random port here. Okay, so once I've done that, I can save that file. And then I'm just going to do the same Docker, not this one. Yeah, I'll do here. It's Docker build tag. Just gonna give my name, and then I'm just gonna go fast API demo, and then the context is gonna be the local. Oh yeah, I have a spell error here that I'll fix. Yeah, the container is built. Let's run the container. And then I do a docker ps. Cannot type. Yeah, the container is running on port 80. You can see here it's forward to port 80. So let's open the browser and then put my local host. There you go, my application is running. So that's about it, Docker. And the beauty of this, and I have another video that I go through deploying this container that I've just demonstrated to you to a Linux instance in Linode. And you solve that problem. It's working on my machine. The idea with Docker is if it's working in Docker, it can work anywhere. So, and then it's making much easier to hand over the application to a operations team, or now what we call DevOps. And thanks for watching. If you have any questions, any comments below. Also, if you haven't subscribed to the video, subscribe, click the bell, like the video. Thanks for watching, and see you next time.